been with the city for almost 3 years now. It's hard to imagine I believe it's been that long, because it feels like I just started yesterday, because I'm new to the public service. I spent 30 years in consulting, and the first thing I've learned since joining the city is we love acronyms. And if any of you got, most of them starting with an A, and if any of you guys were here in the 80s and early 90s like I was, you heard of Project Apricot. It was the city's citywide potable reuse, public access reuse project, delivering reclaimed water to literally every property within the city limits. It stands for a prototype, realistic, innovative community of today, and of course started at the same time as Epcot was starting up in Central Florida, so that's why the catchy name. But the city was really an innovator. What's now very commonplace throughout Central Florida at that time was one of the first of its kind. DEP developed regulations for reuse at that same time, and they came up with the concept of one general permit per utility. Before that, you would have had to have a separate permit for every property you were delivering reclaimed water to. So imagine that when you're delivering it to every house to have to get a separate permit. So they really did break some ground. The project I'm talking to you about today is another A project, AFIRST. It's for Altamonte Springs-FDOT Integrated Reuse and Stormwater Treatment Project. And actually all the planning of it happened before I started with the city, so I can't take credit with that, although I've had the pleasure of helping implement it. I started the day they picked the design consultant for the pipeline portion of it. I've been on a consulting team that was pursuing that work that didn't get it, but knew about the project ahead of time. And I just wanted to introduce also Elizabeth Thomas, who's here in the audience. She was my predecessor at the city of Altamonte and was responsible for some of the planning that took place and helped this project get implemented. You've heard a lot about this today. I couldn't have asked more for the setup and I hope I live up to everything. Wait till Joanne talks. But the big part of this project is the FDOT portion of the name. What started it was I-4 was going to be widened through Central Florida, and the city of Altamonte Springs sits right in the middle of that widening. It's a 21-mile project, a small portion of it through Altamonte that's going to put new toll lanes in the center with 15 interchanges and $2.3 billion project. And even before our current public works director, the city of Altamonte recognized an opportunity here with stormwater reuse. But as Rick Renna pointed out earlier, you got to get into that process early. And even though we were early at the time, they needed to buy land for the stormwater ponds and the holding ponds, or the project wasn't going to happen. So they had to move forward. So the project kind of died. And our current public works director, Ed Torres, who many of you know, picked it back up. And so they bought the land, but they haven't built it yet, and there's still an opportunity here. To give you a little background, this is the I-4 widening through Altamonte Springs, and okay. I said I wasn't going to do this when I watched everybody else falter with this, but I want the pointer. This area here, the DOT bought land for their multiple retention ponds along I-4. This was a big area within the city. It was bought, the houses were condemned, torn down, ready to build a pond there, but we were able to stop the project before that happened. We happen to have a stormwater system called Crane's Roost that sits here right in the middle of the city. It's a focal point of the city. It's a feature. It's been turned into kind of a lake feature. The current or previous operation of this stormwater facility, it's a landlocked basin, so it's pumped to the Little Wekiva River when it reaches a certain elevation to prevent flooding in the area. We could not take more stormwater into that basin and still continue discharge to the Little Wekiva River, which is a protected basin, but we did have the capacity to take it if we could just pump it somewhere else. So that's where the idea of integrating it with our reuse system came about. This is Crane's Roost. We have major events there. This may be the 4th of July festival. It's actually the 3rd of July, called Red Hot and Boom. We have a big Christmas festival. So even though it's a stormwater feature, it's very important to the city. The operation of this system as a stormwater system involves pumping the water. It's underneath I-4, pumping it previously to the Little Wekiva River, and now our new project is to pump it into a treatment system. Part of this project too, even though DOT had already purchased the land for the stormwater pond, they hadn't built it yet, so they can avoid the need to construct and operate it, but also by able to take more water into Crane's Roost and pump it out They were previously going to have to build a bridge over Crane's Roost, and we helped them avoid constructing a bridge, which was an incredible cost savings and helped their ability to fund the project. This is our regional water reclamation facility. The other side of this project is we have this facility that supplies the water to Apopka, our public access reuse system. It's as close to 100% reuse system as you can get. During the hot summer months, we have to augment it with potable water, but during the rainy season, we still have a discharge. It's a small amount, but there is a discharge to the Little Wakaiba River also. And we're being faced with TMDLs, which we're going to make us have to go to very high levels of treatment, RO treatment, membrane treatment, or eliminate the discharge. So while we're looking at this ability to add more stormwater to our reuse system and maybe dampen some of the need to augment our system, we still have this discharge problem. So some of the options for the water reclamation facility would be to just build a lot of storage ponds so we can truly use 100% of our reclaimed water to avoid the discharge, or go to that drinking water level of treatment where we'd still discharge but remove all the nutrients. On the stormwater side, we could keep pumping from Crane's Roost into the Little Wakaiba River, but we would not have been able to accommodate the I-4 widening additional water from that project. And the city wanted to continue being in the forefront. We like those acronyms. We like the apricots. We wanted our next A word to come into play. So that's what brought this project forward with what was at the time an unconventional solution. We did modeling to support our project to show that we could still provide the stormwater volumes we needed within Crane's Roost. And of the about 1.5 MGD on the annual average is going to be treated through a regional treatment system. I know this looks bad from up here, but it's really easy to go the wrong direction. From this map, you can see all the purple here is our purple pipe public access reuse system. Crane's Roost is here in this area, where we're going to take the water, pump it. We happen to have an old water plant that had been decommissioned, so that's the site of a new stormwater treatment system. In Florida, you can use stormwater for irrigation and reuse without any treatment, as long as you're using just stormwater. But once you blend it with reclaimed water, you're required to meet the requirements of Chapter 62.610 for public access reuse. And as a utility person, I have to support that. We don't want to do anything that would ruin the integrity of our reuse system. But I know there's been a lot of questions about that and trying to get more projects pushed forward. There may be things we could do that don't require as the same level of treatment, still be protective, and that's probably something that needs to be examined. From our treatment system, we call it a reduced augmentation facility, or RAF. We pump into our public access reuse system. So 1.5 MGD annual average will be pumped into our reuse system only when Crane's Roost reaches a certain elevation. It's only at a flood elevation that we start pumping. Pumps into our reuse system. If we cannot reuse it within the city, then it gets pumped almost 6 miles to the city of Apopka. The city of Apopka is an important part of this puzzle. They are being faced with some of the water supply issues we've been talking about in Central Florida. Their service area is much larger than the city of Altamonte. They did not have enough water to meet their irrigation demands, so they were seeking reclaimed water from other utilities. They also have the big reservoirs, I think that was mentioned in the previous discussion, to help store reclaimed water. So even during the wet weather, they have the ability to take water when to help us avoid that discharge to the river. This just shows the size of the service areas. Here's Little Altamonte. We have a population of about 50,000, and the city of Apopka, much larger. The little squigglies are the springs in the area, and just this, we're in the middle of several converging areas where springs protection and other water quantity as well as water quality issues come into play. On the stormwater side, the project is allowing us to reduce our stormwater discharge to the Little Wakaiba River on average by 50%. What it's doing is cutting these peaks. I don't want to go into a lot of detail, but this we're essentially cutting off these the time periods when we had You see some years circled. We're cutting out those flood years we normally would have been going to the Little Wekiva. The bottom line of this is we're going to be reducing stormwater discharge to the Little Wekiva and reducing nutrients, about a little over 3,000 pounds per year of nitrogen and 600 pounds phosphorus. Even larger is what we're reducing on the wastewater side from our wet water discharge. Even though the volume is small, the nutrients are high, so we're going to be eliminating almost 60,000 pounds of nitrogen per year and 27,000 pounds of phosphorus a year by this project. On the water supply side, we're providing a total of 4.5 MGD of additional water to the city of Apopka. 1.5 of that is coming from the Cranes Roost stormwater side. The remaining 3 MGD is from our wet weather discharge to the Little Wekiva. It wasn't apparent in my talk. I had to cut a lot of this out to fit in the time frame, but the 1.5 MGD, about a half of that, about a half an MGD is actually coming from I-4. The rest would be coming from our watershed and what we'd be reducing from our normal discharge to the Little Wekiva. The project is now constructed. We started operation back in September. This just shows some of the components. Some of these are pre-construction, but that's just, we had to build a larger pump station adjacent to I-4 to take the water from Cranes Roost. We put in 2 200 horsepower and 2 700 horsepower pumps and generators. We built what we call a reuse augmentation facility at our former water treatment plant site. This facility includes cloth disc filters, chlorination, storage, and then pumping into our reuse system. There was an existing pipeline that led from that pump station almost to this water plant site, so we just had to refurbish that pipeline and build an extension. And then we built the almost 6-mile long, 24-inch diameter pipeline to the city of Apopka for taking the excess water. It's a goal of the city of Altamonte to use as much as we can within the city and then deliver the extra to Apopka. The cost was, including the project budget was $12 million, but including the construction budget, but including design, easements, engineering, and everything, it came in about $12.9 million, which was just 3% off the estimate. And Ed Torres, my boss, likes to brag that they did this like pretty much on a napkin, like you do a lot of projects at this time. And so just to have it come in so close to what they estimated was pretty amazing. These are some of the after construction pictures. This is the reuse augmentation facility, the storage tank, the filters. This is actually at Apopka. This is a flow control structure, and that's their tanks. And these are the big pumps we put in at Cranes Roost. Some more photos. This is a pressure control assembly, so we can control and measure how much water we're sending to Apopka. This slide was shown earlier about the right people in the right place at the right time. As I mentioned, this project was envisioned much before it happened, and I think it also took a lot of persistence with the right people. A lot of people would give up saying they already bought the land for the ponds, this project isn't going to happen. But there was still opportunity there. This isn't a cookie cutter type project. It's not, you're not going to be able to build this exact same thing somewhere else, but I hope the lessons learned is look outside the box, and with persistence, there are ways to make things happen, especially if it's something that makes as much sense as this did as far as eliminating the nutrient discharge and providing alternative water supply. Just give some shout outs to some of the people involved. We had a number of engineering firms. Pegasus and Devo did our stormwater modeling. Reese Engineering did the stormwater pump station in Forest Main. Tetra Tech, our reuse augmentation facility, and the pipeline to Apopka was by AECOM. Construction was with Wharton Smith and Lane Heavy Civil. These are some of the benefits we've gone through as I was talking, but it's a major alternative water supply that alleviates unmet demands in the Apopka service area. It reduces groundwater pumping needs, which helps protect spring flows and MFLs. There's significant overall nutrient reduction to the Little Wekiva River from non-point and point sources. And this will have ancillary benefits in the springs, which have been noted to be having nutrient impacts. It addresses stormwater treatment needs for I-4 and Altamonte and will serve as an example, as we've already heard during the CFWI process. The doors were open to entertaining other options, and this environmental look around is now happening to help identify other opportunities. And besides the environmental benefits, it's saving about $15 million to DOT just from not having to construct that bridge and not to have to operate the stormwater system. Some of the team members involved, Elizabeth even got in the picture, even though she left the city, we still love her. What's next? We're not stopping here. We might need to come up with another A name, but our next goal is to look at potable reuse. I know that's been a big focus of this session, and my paper is different. It's not about that, but it is something we're pursuing. We have a project now, hopefully under consideration, with St. John's River Water Management District for grant funding, and would like to be helping out with this next generation of water supply. Even if our feelings are, even if we're not at that point, we're not having the critical droughts, we need to be prepared for the future. So developing those regulations now makes sense instead of doing it on the fly or after the fact like they had to do in Texas. So if this is someplace we may need to be in even 15 years, we need to start the work now. It can take 5 to 10 years just to develop the regulations. One thing that we think makes us a unique for this, our other A word, is our science incubator program called AS2I, where we bring in several thousand middle school and high school students into our plant during the school season, going through some different experiments, but we'd love to integrate a potable reuse project into that and expose these young minds that can take it home to their parents and into the future that, potable water, potable reuse, it's not a big deal. There is no yuck factor to it. We believe you need to start young to get that mindset started. That's the end of my talk, so we're holding questions till the end, so I guess introductions are next.